In class. We'll be talking about congruence today. Notice we've started Unit 1, which is similarity, congruence, and proof. We'll be talking about congruence and basically only congruence today. A little bit of proof, not really similarity. Our goal today will be to determine how the triangles are congruent. So first things first, we need to know, is there a difference between the word equal and the word congruent? Yes. When I say equals, I mean numbers. So I say 3 miles is equal to 3 miles, or 9 miles is equal to 3 miles times 3 miles. That tells me that I have, 9 miles would be equal to 3 times 3 miles. So equals is when I have numbers involved. Equals is when I'm talking about a distance or a unit of some sort. When I talk about congruent, I'm talking about a shape. So to define congruent, think same shape, same size. So if you're talking about two numbers, just like an equation, you use an equal sign. When you're talking about shapes, a triangle, a polygon of any sort, a rectangle, a circle, if you're talking about two shapes that are the same shape and the same size, we use the word congruent. And if you've forgotten what the congruent sign is, it's the equal sign with the little squiggly above it. So that is the congruent sign. All right, for two triangles to be congruent, this is a lot, so make sure you take it all in, write it down carefully, don't get your words mixed up. For two triangles to be congruent, all three sides of one triangle must be the same length as the three sides of the other triangle. And all three angles of one triangle must be the same measure as the angles of the other triangle. So that basically should make sense to you. All the sides must be the same and all the angles must be the same. Let's look at an example and see if these are actually congruent. So let's start with our angles. Does angle A have a partner that it is congruent with? Well, let's see. Angle A has one arc in it. If I look over here, angle D has one arc in it. So angle A and angle D are congruent. Next, let's move to angle B. Angle B has two arcs in it. Let's see if there is a partner for B. Yes, angle E has two arcs in it. And angle C would be last, which y'all probably figured out by now. Three arcs. So angle C and angle F are congruent. So these little arcs help us match them up, right? Angle A has one arc, angle D has one arc. So those two angles are congruent. Next, let's look at the sides. Let's take the first side over here. I'm just going to go kind of in order here, alphabetical order. So AB, side AB. Is that segment congruent to a segment over here? So notice there's one hash, there's one hash. So that's the same as DE. Now let's go to BC. Notice I'm putting the line segment over it because I'm using congruent. If I didn't use that line segment, I'd be saying the distance from B to C. B to C is 2 hashes, and notice E to F is also 2 hashes. And then last, let's come back to A. So CA. Is CA congruent? Let's see. CA is 3 hashes, and FD or DF is congruent. Doesn't really matter which order you put them in. Remember, the order on a segment does not matter. All right, so do we have 3 pairs of congruent angles? Yes. Check. 3 pairs of congruent angles. Do I have 3 pairs of congruent sides? Yes, I do. So check that off. So what that tells us is that yes, triangle ABC is congruent to triangle DEF. Now there's a few other things to note here. Number one, these letters are in order based on the sides and the angles that match up. So check A, check D. First two, notice A and D are congruent. B, C are the second two, notice B and E are congruent. C and F, the third ones, notice they do match up, they are congruent. That's how we know they're congruent and they're in this order. So this is the correct order. We cannot write triangle ABC is congruent to triangle FED because F and A don't match up. This is wrong. You cannot do this. Last thing I want you to note here is that in this case I use symbols. You could use numbers. But trick is, if you're figuring out triangles are congruent, check all the sides, check all the angles.